Hi, everyone. Prof. Gordon here from Exam Success. And we're going to talk about a concept that I think is going to show up on your exam. It's something which is used in the world of investment finance. It's based on statistics and it helps investment analysts to make predictions and decisions. This is the normal distribution. And when we talk about normal distribution, analysts look at the historical returns for an investment, let's say a stock, and they look back over all of those returns and they come up with a picture that looks like this graph. It's a nice bell shape, and this shows all of the historical data, all of the outcomes, if you want to talk in statistical terms, 100% of all the possibilities. Right here in the middle, this is the expected value. It's the average. In statistics, we say it's the mean. For our purposes, we need to know that's just the expected or the average value. And the term deviation, and in our material, standard deviation. We can divide the area under this curve into standard sizes. And those sizes are referred to as one standard deviation away from this expected value, or two standard deviations, or three. That's what we need to keep in mind. So, from our material, we know that if we are looking at lower and upper limit that is surrounding this expected value. If we go up one or down one standard deviation, then about 68% of all of those observations or all of the returns will fall in this range. If we go two standard deviations above or below the expected value, about 95% of the observations will now fall within this range from this lower limit to the upper limit. And if we go three standard deviations below and three standard deviations above, from this lower limit to the upper limit, about 99% of the returns will fall within this range. So we've got 68%, 95%, and 99%. We need to keep those in mind and we can apply it and answer simple questions. So to be able to do this, let's just apply the concept. So let's suppose we have the following data for a stock. This will be given in your question. The expected return for the stock is 6%, and the standard deviation is 3%. Once we have this information, we can use that normal distribution to identify certain ranges. So we are able to find the upper and lower limits. So we're going to go through finding the upper and lower limits for plus or minus one standard deviation, plus or minus two standard deviations, plus or minus three standard deviations. Now, on your test, you're not going to get all three of these. You're just going to get one, and it's going to be a nice, easy mark. So, how do we do this? Well, we use a simple formula. The formula that we're going to use is the limit is the expected value or the average plus or minus the standard deviation multiplied by the number of deviations away from that expected value. So to calculate the upper limit, we have the expected value plus the standard deviation times the number of deviations. And to calculate the lower limit, we have the expected value minus the standard deviation times the number of deviations away from the expected value. So it's the same formula. This is the plus or minus. That's what we need to keep in mind. Well, let's apply this to an example. So here's a normal distribution. The expected return, the historical average, this is 6%, just like we gave before. So now let's use this to find the upper and lower limits if we go plus one or minus one standard deviation away from this expected value. Well, the upper limit is going to be the expected value plus the standard deviation times the number of standard deviations away from the mean. 3 times 1 is 3. Make sure we do the order of operations correctly. 6 plus 3 is 9. So the upper limit is 9. And let's find the lower limit. Applying our formula, expected value 6 minus 3 times 1. 3 times 1 is 3. 6 minus 3 is 3. So the lower limit is going to be 3%. So what does this mean? Well, now we can interpret this. Plus or minus one standard deviation, there's about a 68% chance that the return will fall between 3 and 9%. That's how we use this information. All right, let's do this example again, this time for plus or minus two standard deviations. We'll use our formulas. The upper limit is 6 plus 3 times 2. 3 times 2 is 6. 6 plus 6 is 12. So that upper limit is going to be 12%. And let's find the lower limit. We'll use the formula again. 6% minus 3 times 2. 3 times 2 is 6. 6 minus 6 is 0. So the lower limit is 0. So now we have this range from 0 to 12. We're plus or minus two standard deviations. So what does this mean? Well, we conclude that there's now a 95% chance that the return will fall between 0 and 12%. Couldn't be any easier. Let's do it one more time, and we'll do it for plus or minus three standard deviations. So we'll use our simple formulas. Expected value, 6%, plus standard deviation, 3%, times 3, the number of deviations away from the mean, or the expected value. 3 times 3 is 9. 9 plus 6 is 15. So this upper limit is going to be 15%. What's the lower limit? Let's use the formula. 6% minus 3 times 3. 3 times 3 is 9. 6 minus 9, negative 3%. So the lower limit is negative 3%. So what does this mean? Plus or minus three standard deviations, we can conclude that there's a 99% chance that the return will fall between negative 3% and positive 15%. This is how we apply the concept of normal distributions. This is how we integrate it with that concept of standard deviation. So I think you got to know this. And a quick summary for you. As soon as you read in a question, normal distribution, this picture should come to mind, this nice bell shape. We've got these ranges. Remember, plus or minus one standard deviation, about 68% chance or 68% of the returns will fall within this range. Plus or minus two standard deviations, about 95% of the returns or the observations will fall between this range from the lower to the upper limit. And plus or minus three standard deviations, about 99% of the returns or 99% of the observations will fall between the lower and upper limits here. That's how we use this information. Nice and easy. If you found this helpful, subscribe. I've got a lot more tips coming. I got a lot of other examples. You can go do free previews of the summary notes, the learning examples, and the practice questions. And as always, you can reach out to me if you have any questions or you need any help. All right, well, we'll end this lesson here.